Hi, welcome to New Electromagnetism Experimental Supplement number 2. In this video, we're going to cover the Paradox 2 through 4 experiments. There's over 54 different variations of these experiments. The reason why there's so many is because when you're verifying a model of nature, the more data you have, the more trust you can have in its validity. Okay, this video will be produced in 2 different versions. There'll be the abridged version for general release, and then there'll be a detailed version for Patreon only. We're going to go into the physics software in that version. Okay, so what we're going to do is we're going to introduce the Paradox 2 experiments. We're going to talk about the naming and the labeling convention. And then for the unabridged version, we're going to go a little bit into the Physics 2 software, look at the results, and then we're going to discuss the near-term schedule of new electromagnetism / ethereal mechanics. And at the end here, we are going to give you, for a lot of people that may not have seen this, an introduction to electrogravity and where you can go find all the videos and the papers for electrogravity, because this video actually dovetails nicely with electrogravity. Okay, so all of these experiments, Paradox 1, 2, 3, 4, are known as the first order paradox experiments. The reason why they're first order is they only rotate in one dimension. And that was the limitation of the old Physics 1 software. It could only do rotations in one dimension. And that's why the new Physics 2 software was developed, because we want to start rotating magnets in higher order dimensions. Or not order dimensions, different. In other words, we want to have rotations inside of rotations. Okay, and so the purpose of these experiments was to analyze magnetic fields in all the first order rotations. Okay, the second order rotations are next, where these are rotations inside a rotation, and also to provide automation for searching and validating the new models of electromagnetism through Physics 2 software. Hopefully, New Electromagnetism V5 is the final answer, but we should never assume we are done, because Mother Nature is really good at convincing us there's no more. And in fact, you should never assume that. So other than basically the naming convention of the Paradox 1, we're not going to go into it in too much detail because it is covered in detail in the previous video. So the Paradox 1 has 8 variants, as you recall from the previous video. And it's covered in these videos here. And the naming convention when data is dumped out is PDX_1 with the code. And the code would be the codes, the AB, ABC, of what the parts rotate. Okay, I think that's pretty straightforward. If you don't understand what the AB, ABC is, that's detailed in the previous video. Okay, the Paradox 2, 3, and 4 all have a unified naming convention. After the paradox, there is a 4-digit code that defines the experiment. The first digit, now they don't have to be in this order. When the software writes out the data, it will write them out in this order, but when you specify to the Physics 2 software which one you want to run, as long as you have a 2 in there somewhere, it'll know what you want a Paradox 2, yada, yada, yada. So the number here represents the magnet configuration. And so we have 3 different magnet configurations, the 2, 3, and the 4. The next one represents the shape of the coil. We have a D, an O, and a Q. And the next one represents what to do with the second magnet. Okay, if you have a Y there, it means, yeah, you're going to have a second magnet and it will be the same orientation as the first. And this would be the default. If you don't supply this to the software, it'll automatically assume you want Y. Okay, if you do not want the second magnet, you put N in there. And if you want the second magnet inverted, you put I. The last one is the coil motion. Does the coil rotate with the magnets or does it remain stationary? This is the default. If you do not specify to the software the coil motion, it will assume you want stationary. And this shows how the software will dump items out to... the reason for all of this alphabet soup here is so you can run lots of different variations of the experiment and not have all the data collide with each other in the same directory. So it creates a directory for each experiment so that your data for that particular run is unique. We'll talk about what these mean a little bit later. So let's get into the 2D. Okay, it's called the 2D because the loop is shaped like a D. You can see it better here. The reason for this little hump here is to give room for the axis of the motor, because these were actual experiments that were done. And these were 3D printed coils. Well, there were 3D printed forms, but the wire was put into little tracks. Okay, we needed to make room for the shaft of the motor, and so, so we can put that into the software to make sure that's modeled properly. Okay, so when you have the 2, means this is the paradox 2 are magnets that are flat in the same direction. Their normals are in the same direction as the rotation. This green line is the axis of rotation for all the experiments, in case I forget. And in the paradox 2, the magnet faces are parallel to the axis of rotation, and the edge is aligned. The edge of the magnet is aligned to the ring, to the edge of the ring. Okay, so if you have an I here, it means the second magnet is inverted. If you have an N here, it means the second magnet is gone, missing. Okay, the S and the R look the same, but in the R case, the coil and the magnets move together. Okay, we got to test all the variations, because as you saw in the previous video, that new electromagnetism V5 says if you have any rotation movement relative to the medium, you're going to get a signal. And we got to make sure we get the proper signals even when everything moves together, which in all these cases should be 0. So that's why the majority of the stuff you're going to see in the output is all 0 output, because in half the cases are rotating everything together to prove that we get nothing out of the simulation. Okay, so that's the only difference between the S and the R. In the S, the coil remains stationary and the magnets move. And this is our standard configuration. Okay, so there's 6 variants of 2D. Okay, now the next coil type is the O. Obviously, it's just a big circular loop. And again, same thing with all the other things. That gives 6 variants of this. Now we have the Q experiments. Q experiments are from the early days, the first experiments we ran, where we had a coil, an O loop, and then we have an armature in the middle that turns with the magnets. Okay, so in the Q experiments, the armature in the middle always spins with the magnets, always. And then if you have the S experiments, the outer loop here is the part that remains stationary. If you have the R in the experiment, then the loop rotates with everything rotates together. Again, just to validate a 0 output. Okay, so with the 2Q experiments, again, there's 6 variants, and these are pictures, and it should be self-explanatory. I'm not going to go into detail. So this is all of the paradox 2 variants, and there's 3 sheets of 6 variants, 18 variants total. So if we go to the paradox 3, okay, there's 3D, there's 6 variants, 3O, there's 6 variants, 3Q, there's 6 variants. I'm only showing 2 pictures to show you the orientation of the magnets. So when you have a 3D Y, okay, both of the magnets are in the positive Y direction. This red is X, Y is this way, and Z is up. When you invert the second magnet, then the north is facing out on both cases. They're facing away from the center of the loop. Okay, other than that, all the other variables work the same, so that's another 18 variations of experiments. And the same occurs with the 4D. In the 4D case, the number 1 magnet, which is right here, its north is facing in the direction of rotation. Okay, and its other magnet for the Y case has got the same orientation. Not in the direction of rotation, because it's rotating the other way. It just follows the same orientation this guy has. When you have invert it, then its face is in the opposite direction as the first magnet. And again, we're going to have 18 variations of this. Okay, the dimensions of the experiments are here. I'm giving these out right now, so in case somebody wants to try their hand using classical theory to model these or whatnot, you can do that. And this is basically for just for recording what was done. Okay, the magnets are 1.26 inches in diameter, and you can see that's recorded in here. The magnet is 126, it's 1.26 inches. It's 125 mils in thickness. That's right there. 2970 amps. Okay, the current is 2970. The gap between the magnets and the coil is, oh, the gap is 125. I am sorry, the thickness isn't there. That's the gap. G is the gap, I is the current, M is the magnet diameter, and RPS4 is the turns per second of the experiment. I think there's more fields out to the right that's being clipped there. Anyway, the wires being modeled are filamentary thin, so all of your dimensions are from the center of the wire. In the case of the magnet gap, it's from the center of the wire to the edge of the magnet. Here I'm showing the 2 configuration of the magnet with respect to the loop, and this would either be the 3 or the 4. And so the gap is from the center of the wire to the edge of the magnet, or in this case, the center of the wire to the bottom of the magnet. Okay, the purpose of again, for the loop in the center is to give a place for the drive shaft to go through and allow the circuit to go around it. The 3.45 inch, it sounds pretty arbitrary, but 3.45 inches is an actual copper ring we have in stock that we've been using for these experiments. So that's why we're using these. In other words, we based all this on actual devices we have in stock that we actually used to gather the data with. We have experimental data for some of the experiments. Okay, now what we're going to do here is I'm going to take a segue to show for the unabridged version for Patreon members how you put all this into the PhysiX2 software. If you are not watching the unabridged version, you will be continuing with the rest of the video now. Okay, so running the physics software, this is the result. Now what this does is it only runs the first 10 points of each experiment. That's kind of why they're all going in the same direction, because all the magnet directions and all the coils were set up so they start negative. That's just the selection of trying to keep everything uniform. Okay, and so what it does is it runs through the first 10 points of the 200-point rotation just to find and it records the max value. So that's what was done with the verification, and that's what was done. And so with the 54 verification, we have excellent agreement. Oh, but the important thing here, I forgot to mention one thing, is we only have 1, 2, 3, 4, 5, 6 experiments actually produce a signal. Okay, and like as I said before, a lot of the experiments are run with everything run together, so a lot of them should be zero output, which is excellent. So what we're going to look at now is we're going to look at the experimental confirmation of these guys here, but we're not going to do all of them, because what it is, it turns out that this guy is the 2-magnet version of this, or rather this is the 1-magnet version of this, and these are the 1-magnet versions of these. So all we really need to do is confirm these, and they should confirm those, because these magnitudes are exactly 2 times. Okay, so that's the important part here. We don't have to do these, we just have to do these. And that's all when I took the data, the year was 2021 when we actually did the experiments to confirm the NEV5. That was the important point, is that we got the values where we should have gotten them, and we got 0 where we should have gotten 0. But we're just going to show you the ones because they have some very interesting signals. Okay, and so we're going to only look at the single magnet versions because they're the ones we have data of. And for the unabridged version, we're going to look at some special phenomenon that's occurring in the 4OI and the 4ON systems. Okay, so this is the 2DNS. This is the paradox 2 with the D-shaped single magnet, and the loop is stationary. Now what I've done here is I only ran PhysiX2 up to the first 200 points. The reason why it's 200 points is because one rotation is 200 points because the stepper motors we use have 200 points per rotation, or 200 steps per rotation. When I measured the data for 2 full rotations. The reason why I did that is because I could never guarantee that the oscilloscope would start at exactly the right point every time. So I had to shift this data back and forth in time, where the simulations always start at exactly the same point. So that was the reason for that. I had to take 2 full cycles of this, and that's why the data kind of cuts out over here, because its data is over here. Okay, so what you see here, we have the 2 components of NEV5. We have the inertial force model, okay, and we have the magnetic force model, which is the triangles here. When you sum them up, you get the black trace. Okay, and the red trace is the experimental measurements. And everything is dead on balls accurate. Now what I did here is, when I did physics 2, again, I only did 200 points, and I left the data, because we already ran all this stuff using physics 1 on the original Vortex B versions of the field models back in 2021. And I left that data here. So what I did is I copied the spreadsheet, and I only filled in physics 2 for the first half. And I left physics 1 left over to show you that we're pretty much getting the same exact answers that we got 2 years ago. Okay, this is the 3DNS, and again, pretty good, pretty good. There's probably a little measurement error here going here. I'm not going to get into too much detail. This is the 4DNS. This is very interesting stuff. Okay, so what we're going to do now, I'm going to take a segue for the Patreon members to go look at the 40NS data, because there's something interesting in there. Okay, coming back. Everybody coming back together, the abridged and unabridged. Now, the people that may not have followed this many years may be asking the question, well, what happened between 2021 and 2023 now? It seems like you already did this in 2021. Why are you doing it again? And that's a very valid question. Okay, because the original breakthrough of the vortex field models was only the magnetic and inertial. I could not explain where the Coulomb field could come from. And so it wasn't new electromagnetism. It can't be new electromagnetism without the Coulomb or the electric field. Okay, but the magnetic and inertial models that were developed, that were used in these experiments, because we don't need the Coulomb model for these experiments, it opened up Pandora's rabbit hole. And that opened up the entire research that led to electrogravity. This is already available. I will put the playlist up there. If not, just go to www.EtherealMechanics.com and you will get to this, and then just go to the electrogravity playlist there. Now, the first 2 videos are a lot of just foundational stuff. Things don't really be interesting until like the 3rd video. Okay, but what happened was the vortex models inferred. I mean, you could look at them and say, oh my God, there is something below all of this. And from that, we're able to infer what's called the pretonic field, a very primordial field, and that's in the video EM302 on page 26. And from there, if you take the time derivative of the pretonic field, you end up with back at the magnetic force model and the inertial force model. So I could show that what we found experimentally can be derived from a primordial field that's at a much lower and primitive level. Okay, and then later on in EM303, gravity and matter, explain inertia of matter, explain the force of gravity and the field of gravity. Okay, people say, oh, is gravity a field or is it a force? Gravity is a field, and the force of gravity is actually electromagnetic induction. Oh, this is the force of gravity here. This is the inertial force. F equals ma. It's right there. F equals ma is right there. So if you go to this video, I show how to derive all that. And the cherry on the top is from EtherealMechanics. I can derive the constant G from natural values. Nobody else can do that. Everybody else, G is an empirically derived value. This is the first time ever that anybody can show you the proper derivation of G from a model of matter. Okay, so we are on the right track at least. Maybe we don't have everything right yet, but we're getting close. It's like when you put a puzzle together. The more pieces of the puzzle that fall together, the faster and faster it goes, and that's what's happening. Okay, and then in the 4th video of the electrogravity series, we derived the electric field, and this was the coup d'etat, the electric field from matter to complete new electromagnetism V5. So there we go. There's Coulomb's model, but modified, because we don't have an electric field from matter unless the pretons, the system is spinning. So if an electron stops spinning, it stops producing an electric field. That's what this says. It'll still have a magnetic field, and this is very important because it shows that, okay, the electric field is a derivative of the magnetic and the inertial force fields. Thank you. No more voodoo physics.